4 a.m. The Kherson front was cold. From the air, the field of warfare was a ghost. But the soldiers on the ground knew better. Silence is never safety. In the pre-dawn darkness, a lone Ukrainian MiG-29 plunged. 50 feet off the deck, it vanished into the tree line. The objective: simple. Survival. Improbable. The pilot had to penetrate enemy lines and strike a grain silo. But this was no silo. It was the nerve center for Moscow's regional drone operations, a hub of advanced defense technology. For weeks, it had directed waves of unmanned weapons. These weapons pinned Ukrainian troops along the Dnipro, methodically eroding their defense. If it stood, the front would continue to crumble. If it fell, Russia's military would be blind. Their artillery would lose the eyes in the sky that gave it its lethal reach. What followed transformed a high-risk sortie into one of the most critical solo missions of the entire global conflict. Stay with us. This war analysis will reveal why. This one flight became the fulcrum of the Kherson battlespace. The MiG-29 entered the sector, hugging the terrain. So low, the jet became one with the contours of the earth. At 50 feet, the ground itself was the pilot's map. Every shadow, every ridge provided cover as the first light spilled across the fields. And there it was, the silo, repurposed by Russian forces into their command center for a new era of modern warfare. From this point, they tracked Ukrainian units. From here, they directed precision strikes along the Dnipro. Destroying it meant blinding a key node in Russia's reconnaissance network. It would halt the flow of drone-guided fire that had bled the defenders for weeks. Phase 1 of the mission demanded absolute stealth. Perfect timing. The MiG ghosted over irrigation canals and deserted farm roads. The air barely stirred. Below, the earth was a blur. The pilot's hand was steady on the throttle. His focus was locked on the ingress corridor, a direct line to the silo. This approach was a calculated risk. Russian radar had a known weakness: ground clutter. Flying low exploited it. The jet had to remain a ghost on their screens. Every second of invisibility brought him closer to the weapon's release point. Then, the calm shattered. A thin tendril of smoke rising from a rooftop. An Igla missile, launched from a concealed position. The pilot knew the signature instantly, a corkscrew trail of smoke arcing toward him. The missile was an infrared seeker, homing on his engine's heat. No radar signature. His SPO-15 threat receiver was silent. No warning, only instinct. He broke hard, rolling the airframe, pulling G's until the seeker lost its lock and the missile sailed past. Another smoke trail erupted from a checkpoint, then a third from a trench line. The pilot understood. He was flying into a layered man-pads trap. They were firing on visual contact, a web of threats from all sides. The MiG went lower still. He dropped the jet below the power lines, crisscrossing the farmland. The cables became his shield. This radical maneuver masked him from the line of sight of enemy radar crews positioned deeper behind the front, a desperate tactic in this war. Each Igla launch demanded a violent reaction. The pilot wrenched the stick, pulling 9 Gs. Every brake burned nearly 200 pounds of precious fuel. His total fuel load, 7,000 pounds. The combat math was brutal. Too many evasive maneuvers, and he wouldn't make it home. But he held his course. The strain was immense, but turning back meant the drone hub would continue its deadly work. He focused on the patterns in the fields below, marking the final run to the target. He fought the controls, steadying the jet through invisible pockets of wind. With every mile, the margin for error vanished. The next stage would be harder. Russia's long-range defense systems were waking up, activating their deeper defensive layers. The first sign was a whisper, a faint searching pulse from a hostile radar. Its signature so faint, it was lost in the terrain's background noise. The MiG flew nap of the earth, a tactic to defeat most X-band systems. But the P-18 spoon rest operated on a wavelength that bent around hills and through tree lines. Its long-wave beam made contact for a fleeting second, painting a brief return on the operator's screen. It was not a clear picture, just a ghost on the scope. But it was enough. It indicated a high-speed target cutting low on a vector that threatened the rear of the Russian formation. The The crew reacted instantly. The contact report was flashed to all defense systems positioned deeper along the axis of advance. The pilot pressed on, unaware he'd been painted by a radar designed not for targeting, but for wide area search. Its purpose was detection, not a crystal-clear image. Ahead, the terrain flattened. The protective cover of the ridges was falling away. He remained focused on his ingress path, but the Russian defense network was already tightening around him, triggered by the P-18's alert. Every military unit receiving the warning went to high alert. This was the moment the corridor began to shrink. Radar and missile crews synchronized their systems, preparing to function as a single, coordinated response. The P-18 had been the tripwire. It initiated the next phase of this layered defense warfare. With a rough location established, the more precise X-band radars came alive. The systems of the Pantsir and Tor M2 began their search patterns. These modern weapons were designed to acquire targets, emerging from terrain masking for even an instant. Their beams sliced through the sky, hunting for the moment the MiG was forced to climb, or cross a clear line of sight. Their operators understood that a perfectly timed lock would mean a missile could reach the jet before it ever completed its attack run. As the radar crews prepared their targeting solutions, the electronic warfare troops in the rear sprung their own trap. The Krasuka 4 system went active, flooding the lone and L2 frequencies with electronic noise. It established a bubble where GPS signals became erratic, then vanished. This interference was a direct threat to the accuracy of any JDAM-ER released inside that zone. The jamming field created an invisible turbulence, making the pilot's mission infinitely more complex. Ukrainian engineers had developed a backup guidance through an inertial navigation system, but the loss of GPS precision was a critical risk. The defense systems awaiting him were no longer separate elements. They were now components of a single kill web, locking into alignment. Radar, missile guidance, and electronic disruption formed an interconnected trap. It was designed to strike the second the pilot exposed his aircraft in the attack climb. The pilot was still pushing forward. The final barrier would rise the moment he reached the altitude required for the strike. What came next would force him to face the most lethal layer of the Russian air defense. The integration of the JDAM-ER into the MiG-29 was one of the most remarkable engineering efforts of the war. The airframe and the bomb were from two different generations of warfare. They were never meant to function together. Ukrainian technicians had created a custom digital bridge, allowing Soviet-era avionics to speak the language of American defense technology. This improvised interface carried the essential data the weapon needed to survive, including target coordinates, atmospheric conditions, and the release profile. The pilot initiated the handshake, watching as the systems began their digital conversation. Each green light on the display was a heartbeat, confirming the mission was converging on its decisive moment. The internal checks were meticulous. The pilot scanned the bomb status on his cockpit display and saw the indicators flip to armed. Navigation data was uploaded. The 40-mile glide path appeared stable. The control surfaces of the JDAM-ER cycled, responding to the test signals. This confirmed the wings would deploy the instant the bomb separated from the aircraft. But another presence was growing stronger: the growing interference from Russian electronic warfare systems. Pressure intensified inside the cockpit. The GPS signal began to flicker, individual satellites dropping from the display. The targeting symbology ghosted across the screen. The pilot understood the danger of this global conflict. Relying on GPS alone was a fatal error. The Krasuka system was active, tearing at the signal. A loss of lock at the critical moment, and the weapon would go wide, far wide of the silo's central structure. The target was hardened with reinforced columns. Only a perfect strike would ensure its destruction. The collapsing GPS link added a brutal urgency. The only fallback was the inertial navigation system inside the JDAM-ER. It was the final safeguard, a key piece of defense technology. Internal ring laser gyros measured every microscopic shift in position. The sensitivity was absolute. The pilot scanned the inertial readouts, confirming the system was tracking. It could hold a 10-meter accuracy for 2 full minutes without GPS. This capability was the mission's lifeblood. A protective layer against the electronic warfare ahead, the INS relied on no external signals. It tracked its own position through memory and the pure physics of motion. It was the safety net in modern warfare, the one element protecting the strike from total failure. Checks complete, the weight of command settled on his shoulders. The bomb was armed and ready. The aircraft was now at the initial point, the start of the climb. The IP materialized below the MiG-29, a boundary line between the shadows and the open sky, where enemy radars waited. The pilot pushed the throttle to the firewall, pulling the nose up into the high-speed maneuver. A pop-up profile, trading raw velocity for altitude. A controlled leap into the kill box. Every foot upward increased his exposure, unmasking him to the long-range defense systems that had been hunting him. The altimeter spun, airspeed bled away. Reaching 15,000 feet was non-negotiable. The JDAM-ER needed that height to generate energy for its 40-mile glide. Anything less, the bomb falls short. Anything more, and the MiG flirts with a stall. The jet crested the last terrain mask. The Russian soldiers watching the Tor M2 console reacted instantly. The MiG's sharp ascent cut through the ground clutter. The fire control radar achieved a hard lock. The signal was pure, a clarity it had lacked all morning. Technicians fed the target data into the guidance computer. The troops prepared for engagement. The Tor crews had run this war analysis. Any pilot employing a glide bomb was forced to reveal himself. This was the moment. The MiG had entered the window of maximum vulnerability. The battery's chance of a kill was at its peak. Inside the cockpit, the threat receiver shrieked. The tone changed, the pitch rising. A hard lock. The radar beams were tightening their grip. He held the controls steady, the G-force pressing him into his seat. The climb stole his maneuverability. The jet was balanced on a knife's edge between lift and drag. The wind hammered the airframe, every vibration running through the seat. Instinct screamed to brake and evade. But the JDAM-ER required a perfectly stable release. Any deviation and the bomb could strike his own aircraft. It could tumble or fail to deploy its wings entirely. The Tor crew launched the 9 M331 missile. It fired the exact moment the MiG neared its release altitude. The missile erupted, a violent acceleration, clawing a path directly toward the jet. The missile rapidly gained speed. Its brain fed constant updates from the ground radar, refining its deadly pursuit of the Air Force target. A piercing tone screamed through the cockpit, a solid lock. The missile icon flashed on his threat display. He held the aircraft steady. The entire mission depended on these final seconds. At 15,000 feet, the release cue illuminated. The pilot pressed the release control. He felt a solid thump through the airframe as the JDAM-ER separated. A breath later, its glide wings deployed. The weapon began its autonomous descent toward the silo. The strike, a key piece of defense technology, was in motion. Now, the pilot faced his own war. The incoming missile was closing fast, forcing him to fight for survival. The moment the JDAM-ER left the MiG-29, the pilot's world shrank to a single threat, the missile streaking toward him. He rolled the aircraft inverted, pulling the nose down, forcing the jet into a steep dive to break the radar's tracking angle. The rush of air against the canopy became a roar as the aircraft accelerated. He punched out a burst of chaff. The air filled with reflective particles, a ghost for the enemy's guidance system. This dive placed tremendous strain on the jet's control surfaces. But it was the only maneuver left to force an overshoot. The Tor missile closed the gap, then detonated 300 meters away. A violent shockwave slammed the aircraft. Hot fragments from the blast ripped through the left side of the MiG, piercing an engine casing. A metallic shudder ran through the entire frame. Warning lights flashed across the cockpit. The damaged engine was losing pressure. No flames erupted, but internal temperatures spiked, triggering an automatic shutdown. The pilot acted fast to prevent the malfunction from spreading. He cut fuel to the dead engine and fought to stabilize the aircraft on remaining power. The hydraulic system took a harder hit than he expected. A cluster of fragments had torn through the lines near the central fuselage, gutting the aircraft's hydraulic control authority by more than half. The backup system activated, but it was only a whisper of pressure against total failure. The pilot felt the heavy resistance in the controls immediately. Movements that were once light now demanded brute force and precise timing. Every adjustment was a struggle. The jet responded with slow, heavy motions. Despite the damage, the MiG held its dive. It was long enough for the missile remnants to fall behind. The pilot leveled out at a safer altitude, cautiously testing the controls. The aircraft shuddered with each correction, as if fighting its own wounds. With only one engine functioning, this was a new kind of warfare. Available thrust was slashed. This forced the pilot to maintain a razor-thin band of speed just to keep the aircraft airborne. Flying outside that margin risked losing control entirely. A slight error, and the troops on the ground would have one less friendly in the air. The pilot understood the fight had shifted. The weapon was on its way, but he still had to escape the Russian air defense network. He had to do it in an aircraft that was now severely compromised. Miles away, the JDAM-ER began its glide with silent precision. Once separated, the weapon spread its wings and stabilized its path, using the altitude gained during the climb. It traded height for distance, closing on the silo. The bomb descended as its onboard guidance system interpreted target data. The data had been uploaded moments earlier. Through its sensors, it made minute course corrections, a testament to modern weapons design. It maintained a steady trajectory, even as an enemy jamming field tried to distort its signal. The silo grew clearer on the weapon's internal map. The gap was closing. The structure had been reinforced, converted into a command center for enemy drones. Its walls were built for weather and storage, not direct strikes. But the war analysis was clear. Its internal support columns were critical. The JDAM's trajectory was precise. The central column, a vulnerability identified by Ukrainian war analysis. Its delayed fuse was the key, allowing the weapon to penetrate multiple layers before detonation, a design feature of modern weapons that magnified its destructive force. The payload would only be unleashed at the target's core. As the bomb closed on the silo, its guidance system initiated the terminal dive. The angle of attack steepened. The weapon struck the upper concrete layer at high velocity. Its hardened casing tore through the first floor. It continued its descent. Each impact shattered internal walls, sending shockwaves through the structure. The fuse's delay, a marvel of defense technology, was functioning perfectly. This ensured the weapon would reach the central support before detonation. The final penetration carried the bomb into the heart of the military installation. There, the fuse completed its cycle. The explosion released 445 pounds of high-energy explosive. A fireball consumed the silo's core. The blast expanded faster than concrete could contain it. The temperature surged. The shockwave radiated outward, instantly collapsing the surrounding support beams. Walls buckled. The floors above pancaked in rapid sequence. The collapse was a chain reaction, accelerating as each layer crashed into the one below. In just over 6 seconds, the structure that coordinated enemy drones across Khorasan folded into itself, vanishing into a cloud of dust. But the destruction was not over. After the primary blast, stored equipment ignited, triggering a series of secondary explosions. They ripped through the wreckage. Batteries, fuel canisters, and Igla missiles detonated in scattered, violent bursts. Flashes of light cut through the rising smoke. Each detonation added another wave of fire and debris until the complex settled into a burning crater. The MiG-29 began its escape on a single engine, blast damage propagating through its airframe. A loss of hydraulic pressure made every movement feel delayed. Heavy, the aircraft shuddered with each attempted course correction. Light flickered across the cracked canopy. Warning tones screamed through the cockpit. The smell of overheated metal seeped into the pilot's mask. The jet's skin, a critical part of its defense systems, had been punctured. Airflow across the holes created a constant vibration, making the controls feel even less responsive. It was a moment of truth for any pilot in this global conflict. Survival now depended on precision, discipline, and the will to push through fear. The danger intensified as enemy troops opened fire. Rapid bursts from 23mm cannons. The guns threw a wall of tracers across the escape corridor. The pilot saw bright streaks clawing upward. Each burst forced another evasive maneuver, though the damaged jet resisted every command. The Air Force pilot kept his altitude low, using the terrain as his shield. But the pressure from the cannon fire tightened around him. The ground rushed past as he struggled to stay below the line of fire. He fought to keep enough lift to remain airborne. Despite the failing engine, the pilot executed a series of sharp, jinking maneuvers. Each evasive move was designed to break the gun crew's rhythm, placing enormous strain on the remaining engine and the pilot's body. He continued to adjust his course in unpredictable patterns, avoiding the incoming fire. He could feel the aircraft losing speed. Every time he pulled away from the tracers, the reduced power caused the jet to sink dangerously close to the ground. The risk of falling short inside enemy territory grew by the second. For these soldiers, capture was a real and terrifying possibility. Even against these odds, the pilot pressed forward, relying on instinct and training to guide the damaged fighter toward friendly airspace. The landscape ahead slowly shifted as he reached the final stretch. The radio crackled. It was the first clear signal since the attack. The sight of familiar terrain restored hope. He guided the crippled MiG across the border. He was flying on the last momentum the engine could provide. It was a narrow escape, one that would set the stage for the final assessment of the mission. The mission's impact echoed far beyond the target's destruction. The pilot's survival forged a powerful symbol for all Ukrainian forces. For the soldiers holding the Kursk line, it was proof. Determination could shatter even the most complex defense systems. The story of a lone jet, returning on a single engine through layered defenses, hardened the morale of the troops. These were units that had endured weeks of unrelenting pressure from enemy drones. In Moscow, the military confronted the sudden loss of a critical facility, a nerve center for daily drone strikes. Its obliteration silenced a huge portion of their operations for several days. This lull in the war gave Ukrainian positions their first real window of relief, allowing commanders to reorganize their defense. International observers immediately grasped the strategic weight of the strike. Analysts across Europe and the United States began their war analysis. They highlighted the operation's efficiency against the scale of the damage. The use of a single aircraft was a lesson in modern warfare. Paired with one precision weapon, it dismantled an entire network of drones and exposed critical flaws in the Russian air defense structure. Analysts call it the definitive example of pilot versus network, a new doctrine of defense technology where a single skilled operator neutralizing an automated system of sensors and centralized command. Western military circles praised the tactical ingenuity. It proved that adaptable tactics at the right moment could overpower expensive defense technology. The strike also exposed a deeper flaw within the Russian air defense architecture. Though the network appeared powerful, it was brittle. Its sensors and response protocols faltered when faced with an approach angle that defied their expected threat profiles. The radar screens lit up, but their timing and coordination fractured as the MiG forced them to react to an unpredictable path. This failure suggested rigidity was a core vulnerability in the Russian defensive grid, raising questions about its ability to counter future hybrid strikes. 2 days after the attack, new intelligence emerged. Ukraine was expanding its operations. This was becoming a broader campaign. Satellite images from commercial platforms confirmed it. A fire was recorded at a long-range radar base near Kursk. Analysts linked it to the same pattern of deep strikes targeting Russian military infrastructure. The event signaled a strategic shift. Ukraine was no longer focused only on the front lines, but was shaping a new strategy. A strategy aimed at crippling the very systems that guided Russian attacks. This perspective changes everything. Russia now stands at a strategic crossroads. Having watched a single Ukrainian aircraft tear through its defenses, what was supposed to be a dense, layered air defense system proved vulnerable. Moscow may now tighten low-altitude protection around every UAV hub. It could push command centers deeper into the interior, or expand its electronic warfare zones to counter these new threats. The goal: to confuse the guidance of modern weapons like the JDAM-ER and blind the surveillance drones before they reach their targets. Ukraine, however, sees this as undeniable proof. Precision timing and a determined pilot can inflict damage far beyond the cost of one sortie. Kyiv will likely refine this single aircraft, single strike tactic, combining MiG-29s, F-16s, and reconnaissance assets from its air force. The objective: dismantle radar networks and sever supply routes. As both sides adjust, a central question for this conflict emerges. Will human pilots remain the decisive edge in warfare, or will autonomous systems ultimately claim the future of combat? Post your war analysis in the comms channel below. Forecast the next phase of this global conflict. Support our mission, engage with this report, and subscribe for every critical military update.